Today it's Friday, 23 of September 2022. Because some people they don't understand what I'm doing and they're placing comments and they're asking or they're suggesting a couple of things. And because I'm a happy person, alright, I'm gonna repeat again. I'm saying that I make test. I know that the setup is not right. I know that the stone is not right. I know I'm not the right guy to do such a thing. Fine, alright? Just trying to correct something here. I have to deal with one stock connecting rod that's bent. Fine, it's twisted actually. I have to deal with one aftermarket connecting rod that's oversized here on the big end. Not where it's stepping the bearing, but where it's between the big end and the crankshaft I'm talking about here, side to side. Alright? And I get an M157 connecting rod that I don't care to machine it to see how it's gonna end up. If I'll be able to do that, if it's fine or not. Alright? Fine up to now. My target is to be straight, to don't have a high spot and low spot here on the big end, on this surface I'm talking about, around. That's my target. To don't exceed the 0.15 of a millimeter and to don't be more tight than 0.1 of a millimeter. That's my target only. Fine. Now, one second because I have a cigarette. Okay. Alright, what I did, like I said, I get one connector that I don't care. That's already bent. I measure it. I have another one that I didn't touch it. Fine. And I try to machine it to see how it looks like. This is from yesterday. This thing is from yesterday from the stone, and this is from the cutting tool. Because today I make another test. I'm gonna show you in a while the results. One second, since I have it here. Yeah, I know the engine room is upside down. It's a mess. I know. I'm not closing an engine. I'm just getting measurements and I'm trying to machine the connectors. Fine. Alright. What I said before, I said that this is not the right tool. It's not the right stone, alright? I was surprised that it didn't have vibrations and had a good clean finishing. I already mentioned that. Regarding the coolant, the cutting oil or cooling, how call it as you like, if you watch on the video, it was half plenty. Even if you put the cooling on the stone, it will gonna spark. You like it or you don't like it. This spins at 5000 RPMs, alright? It does spin at 300 RPMs. Even if I put the coolant here, let us say, it will gonna spark. If you're not believing me, ask some machinist that he knows better than me. Fine. This is a custom bracket to hold it here on the neck. It's aluminum anodized. I was afraid about that. It's working fine. I mean, it's not from so precise job. I'm gonna explain what I mean, but it's working. Surprising, it's working. Fine. Alright. Now, what I have here, just to have one idea what's going on. Alright, today I machine this connecting rod. Let me show you with what tool. I'm gonna go outside on the lathe. Well, man, give me a minute. When I click the record, you start this one. Just less than a minute. With this one, I machine today the connector. So this is what I did today. Fine, this untouched. And this paper comes here. Fine. This is the stock connector. Yeah, this was with a stone. This is the same connector rod that I machined yesterday with a stone, and today I measured it better, let us say, with a clean mind, how much it was. Alright? So, by measuring it, in which spot? You're measuring here, let us say, here, 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 and here, in different spots, all around. Alright? I found this. Forget that, like I said, it starts the stone grinding, let us say, from outside inwards, and then it has a ramp. Alright, it's not correct. I explained already that. I already explained that. Don't make me repeat myself. Alright, what dimensions you find? You find the highest point 0.813, alright, and the lowest 0.785. The difference it's 0.28. Correct me if I'm wrong. No, I'm not wrong. This is how it's supposed to be. Yes, 0.028 of millimeter. This is how much will gonna be the difference from one side to the other side. That means the lowest spot and the highest spot. Fine. This is with the stone. The stock one, untouched stock connecting rod. Fine. Here, if you measure the different points, again, if you make this measurement 3 times, you're gonna see plus minus 1000 millimeter. That's what I'm getting with this tool with my hands here. Alright, at 25 degrees, 26 degrees Celsius. Alright, So the lowest it's 952 and the highest it's 974. That means the difference is 0.022. I'm talking about M157 connecting rods. That's a demo just to see with what I have to deal with. Alright, fine. This is a stock one, untouched. This is the results with the stone, and these are the results with the bit. Alright, now you see what I didn't do? I didn't do it how much material I remove from the stock with the stone and how much I remove from the stone to the bit that I showed you earlier. Let's make the average. What I mean by that, adding the highest and the lowest, divide 2 to see how much the average in all of them, and I'm going to tell you how much I remove from the stock one with the stone and from the stone to the big. Alright, this is supposed to be, let us say, the 0 example. 1 second for you, 1 minute for me, something like that. I'm going to reach the point. After that I'm going to show you the stock connecting rod and the aftermarket. You have already shown you the aftermarket. Okay, yeah, just give me a second. Alright, stock connecting rod, untouched, big end here, the width, talking about here. Alright, let us say that it's 19.963. That's the 0. Fine. Now with the stone yesterday, because I'm not familiar with the stone, I cannot machine it the same like a bit. I'm more familiar with the bit. Alright, with the one that I showed you again earlier, that I went to the lathe with this tool I'm talking about, with the cutting tool. Okay, with the stone I removed yesterday 0.164 of millimeter. That's too much. I don't want to remove that much, from the first place. So like I said, if you add the high and the low and then you divide by 2, then you have this number. The same thing if you do that, the same thing here. High with the low, divide 2, you find the number. Fine. So I removed 0.164 of millimeter with the stone yesterday. Today, if you compare the measurements from the stone to the bit, to the cutting tool outside, I remove 0.032 of millimeter. Alright, it's much more acceptable for me from what I'm trying to do. Alright, and I can make it even better. I was not careful with the connecting rod. I don't care. It was a little bit slap, if you like. Yes. Now let's see something that it's good results for me, at least. With the stone, like I said, I had a difference, high points and low points, and it has a ramp also, high and low to 0.028 of millimeter, 2800 of millimeter. Fine. With the bit, what I have, it's different story. The highest it was 771, the lowest it was 763. The difference, you see the numbers actually, right? There is no, I didn't make any mistake. Yeah, it's 8000 of millimeter. To me, to my eyes, this is much better. And the finishing, it's fine. I mean, if you see the finishing, I don't see any problem. I might polish it with a 2000 sandpaper at the end. I might put down one 2000 sandpaper and polish it on the stone there, just slightly, with some polishing cream to be nice and shiny. Well, we're gonna see about that. But to be honest, it's not gonna matter. But anyhow, you get the picture. Now, with the bit that I have more experience, if you like. Yeah, I'm not machinist by any means. Alright? I'm just trying to fix it working and to be on specs. That's what I'm trying to do. Now, with the bit, with the one that I show you, the cutting tool, I remove 8000 millimeter. No, sorry, 3200 millimeter. With the stone, I remove 164.164 of millimeter. Alright? For me, this, I like it better. Like I said, my target on this connecting rod, on the specific connecting rod that has the high spot, is to make it straight first, alright? And then remove the extra material what has from one side. That means, like I said, this side is 0.73, this side is 0.82. So cleaning this surface to don't have a high spot and low spots. You see that? You see that here it's shiny, here it's shiny, here it's not. And this connection didn't run even for 1000 kilometers. It ran normal break-in, if you like, for 1000 kilometers. Alright? So from one side, that this is the lowest, if you like, I want just only to clear the face and to don't have so much uneven surface. Fine. If has, let us say, the difference 8,000 of a millimeter, that means in some spot it's 8,000 higher and 8,000 lower, for me it's acceptable. For me, keep in mind that I'm looking for 1/10 of a millimeter to 15 of a millimeter. You see, 0.15 to 0.1. So for 8,000 of a millimeter, it's more than enough. It's beautiful. And if I make a couple of tests on the MO57 connecting rods and I put a target where I want to be and I make it, and I have my target and I get used to it, let us say the tool, and my eye to use, let us say, or let us say when you're adjusting how much you're gonna push the tool, you're gonna be fine. I'm gonna be able to do it properly. Yes, I have to make some tests. Yes, I have to do it on a dummy connecting rods that I don't want them. But at the end of the day, I want to make sure that I'm gonna be able to machine it properly and I'm not gonna destroy the connecting rod. Fine. So this, like I said, from this side, to make it as straight as possible, it's different to have 1/10 of a millimeter, example, and different to have 8,000 of a millimeter. Fine. And from this side, because it's more thick, to remove more material to give me the 0.1 to 0.15 millimeter clearance. That's what I'm trying to do. Now, if I had, let us say, the jet for the cooling here, or if I had it on the plate, or let us say the stone is not right. I've already mentioned all these things. Gentlemen, with all due respect, I already mentioned this. I'm not trying to be a machinist. I'm not this guy. I'm just trying to help my friend with the connecting rods. The connecting rods, as the connecting rods, they're gonna handle the power. Just the cut, it's not right. Alright? That's it. That's what I have to say. So, and that's what I'm gonna do today. Yay, how lovely. Over and out. I hope that you get the picture. We're gonna see that again at the end when I'm gonna finish it. And when I have good results, oh no, any result, whatever result I'm gonna have, I'm gonna make it on the video. When I'm gonna finalize it and I'm gonna be ready and I'm gonna check it on the crankshaft and I'm gonna see that it's okay, I'm gonna show you, I'm gonna make a video, you're gonna see the connecting rods on the crankshaft, you're gonna see that which filler cage will gonna go inside, which one is not gonna go inside. What's the maximum that's seized and what's the minimum, let us say that it does have a space. Same thing, how I check the rest. Fine. Once again, I cannot find stone here in this country. I tried even 2-3 years ago. I don't even remember why I need that tool. I fix first the bracket, I get the tool, I fix this bracket, but I don't even remember why I want this tool. I cannot use it, like I said, with this stone. And I'm supposed to fix another tool here that's holding it with different support from back there. It looks like it's working fine. For the job, what I want to do, yes. Plus, I'm gonna repeat this again. I have repeated that in the past. I'm gonna put this on the video. This will gonna be the end. The lathe is a China-made lathe. Nothing wrong with that. I'm not saying that it's garbage or something, alright? It's not bolted down, alright? There is additional, this step, what you see, and this one, it's stepping on the wooden floor. This is wood, it's not a concrete. The ideal, if you're asking me, you're supposed to bolt down the lathe on the concrete properly. How is the lifts? How's the lifts over there? Before you bolt it down, you have to measure it to see that's correct. You have to put a long bar to see that it's not bent or something, and you have to read it from a side to side, front and back, everything, and then you have to support it down and to do precise machining. All right, not like this, not like this. I have mentioned that before in the past. I'm not looking. I'm gonna be happy if I am within 100 of a millimeter. Since I saw that I'm 8,000 of a millimeter, it might be, you're gonna tell me, okay, it might be just you was likely, let us say, with that. Yes, you're right. That's why I'm gonna test again, and when I'm gonna be confident that what I'm doing it's right, then I'm gonna try to apply on an aftermarket connect rod and make it properly. I might make 1, 2, 3, 4 tries, let us say, on the connecting rods, measuring, let us say, keep the measuring this one, then machine it again. Let us say I'm gonna put a target that I want to remove from here 9,000 of a millimeter, example, or 1/10 of a millimeter, not 1/10, 100 of a millimeter, example. Let's see, I'll be able to remove 100 of a millimeter correct, equal, without having high spots. If I have 8,000 millimeter high spot, it's fine. Yeah, 300 millimeter, a little bit more than 300 millimeter. I remove from this between how it was before with the stone I remove 300 millimeter. All right. Can I remove 100 millimeter or 200 millimeter? This will gonna be my next step. You're gonna tell me why you remove 0.032. Why? Because of this. Because I have 0.028 and I want to make the surface flat, straight, zero. And again, if you see here, it's not. You see, this is what I'm saying, that's the ramp because of the stone. Let's see, I'll be able to remove 100 millimeter that I want to go slowly and make my clearance how much I want to be. Again, I'm not trying to be a machinist. I'm not a machinist. I said that before. I'm not an engineer. Alright, different to be a mechanic, different to be an employee and just a mechanic, different to be a machinist, different to be an engineer. Alright, fine. Just trying to find a way to save the connection rods. That's all. Nothing more, nothing less. Thank you very much. I haven't uploaded yet the video. Since I haven't uploaded yet the video, I went and I get another pass from here. And now you see that disappear completely any mark from the stone from the previous machining. Alright? Stone, this, maybe I'm right, I'm wrong. I'm calling it a bit, the cutting tool. Okay, that's how I'm calling it to separate it. Let's get now a measurement of this pass to see how much I remove. Alright? We are in average 767. Let's see how much we're gonna be now. Let's see the results. Now, like I said, this pass that I did, this cutlet I said that I did, it's 738, 734 is the lowest, and the highest is 742. Alright? That means I have a difference 8,000 millimeter. Same thing also here. It's remaining the same. Keep in mind, it's been centered, not up and down, only in and out. Alright, it's not been centered. I'm not using the independent choke. I'm using it with a 3 jaw, the choke, and it's centered by itself. It's not 100% accurate. That's what I'm trying to say. But in and out, this face, it is. Alright. So what do we have? How much material I remove? Before I machined it was 767. Now it's 738. That means I remove from before and after 0.029. Fine. From the stone I remove 0.032, and from this side, the next step it was 0.029. 300 millimeter. I'm gonna try to make it as low as possible. When I'm gonna put the actual connection that I have to measure, I have to machine it. I will have to measure it with a micrometer to see that it's okay, that's true, and how it's gonna be. You have to measure also outside here. You have to measure also inside here, to make sure that it's not gonna be sideways. It's gonna be correct straight inside, because you have a problem with these surfaces. With this it's more easy because it's much more straight. It does have so much high spot and low spot. And don't forget that the M157 has plenty of space on the crankshaft down. This it doesn't have, or this one. Fine. So this is, like I said, the highest spot, it's 410, the lowest it's 394, it's 0.16, 0.016, sorry. A little bit less than 200 millimeter. Alright, again, I didn't feel that on the filler cage. When I put the 0.12 inside and I was spinning it, I didn't feel that bites something. The 0.12, it was, I couldn't put the 0.13, it seized the connection after that I cannot spin it. 0.12, it goes there and I'll be able to make 360. So I guess I'm fine if I have, let us say, something like 100 millimeter and out on the highest spot, because here I have 8,000 millimeter. It's supposed to be okay. The stock and it's almost 200. All right. So that's my plan. Wish me luck.